To find a y-intercept on here goes pretty smooth. You can plug, it's essentially we're just plugging 0 in for the x's everywhere I look. You can do it in the factored form or in the original form, but we're just plugging zeros in and seeing what happens. If I plug it into the factored form, it's pretty quick. This is even faster because 0 to the third and 0 squared are all 0. So this is just 0 plus 0 minus 12 times 0. So it's 0 plus, oops, here, we'll put that down there. 0 plus 0 minus 0 on the top, so that's nothing. And then this is 0 plus 0 minus 12, so negative 12 on the bottom. So we just have essentially just 0 on the top over negative 12, and so that's just 0. And so you may have suspected this from before, if you happen to notice that happening in the x-intercepts, but this is the y-intercept is 0 as well. Okay, only other concern in these questions is we have to find the horizontal asymptote and describe that. And so quick take on that is this one we have noticed that the top power, the power of the numerator, is bigger than the denominator, than that of the denominator. This is x to the 3 over the x to the 2. So if we scribble out all of the other stuff, the other terms, the little terms, and find out what happens as x approaches infinity, kind of like when it's an end behavior thing, you know? And so horizontal asymptotes really are an end behavior thing, or a long-term behavior, long-run behavior, whatever we call that. And so we're going to cross out all the smaller powers, and we'll just look at what happens x to the 3 over 4x2 as x approaches infinity, you know, as x goes out to a billion. And so if you're looking at this, it simplifies down. X to the 3 is x3, and then this is 4 times x, so x2. We'll cancel those two x's, and then this function simplifies to being essentially just x over 4. And so what happens now if I simplify that down, and I imagine what happens if I start plugging in a billion. Let's see here. If I started plugging in a billion for my x's, that means I'm getting huger and huger numbers on top. A billion over 4, even though I divide it by 4, this is a humongous number. And so it seems that what's going on is as I plug in bigger and bigger numbers, the function value itself just keeps on growing, because if I plug in a bigger number, I have a bigger number to divide by 4, and so it keeps growing as well. So then we'll say there is no x-intercept, or sorry, what do they call this? There is no horizontal asymptote, because a horizontal asymptote essentially means that your graph at some point is leveling out, almost, you know. But this one seems like the farther out I plug in x's, the farther out it keeps on going uphill with the function value, because it just keeps growing bigger. And that's the case when you have a bigger power over a smaller power. We just say that there is no horizontal asymptote. I'm just going to put HA. There's no horizontal asymptote because the higher power is bigger than the top power is bigger than the bottom power, or something like that. Okay, similar situation here. On number 15, we would handle it similarly in every way. We would just, you know, we're looking for the holes and versus the vertical asymptotes and all that. Only thing I would mention about this one, guys, see what you can do on it, but when it comes down to factoring it, I do recommend taking out a -2 before you start getting into the further factors. That way you don't have all these weird negatives by your x squared and stuff. So take out a -2, then it'd be like x squared plus 1x minus 2 or something, and see if you can factor that further. That might go well for you. I don't think there's any holes in this one because I don't think these will match that either. But skipping some of the detail, I wanted to mention here, this one has the power on the bottom being higher. So x to the 2 on the bottom and x to the 1 on the top. And we got to look at what that looks like in the long haul. So if we were to say, here, let's scribble that out for a second, x to the 1 on the top, x to the 2 on the bottom. Now we'll suggest, well, if that thing factored down, this is 2 x's and 1 x. So if I were to cancel it out, we have just essentially a 1 over x is what happens. And so what happens here, guys, is if you have a power on the bottom bigger than the power on the top, then as you plug in numbers like a billion, you'll essentially have, this will be like 1 over a billion, or 1 out of a billion, which is a teeny tiny fraction. 1 out of a trillion, 1 out of whatever. And so as we keep getting bigger and bigger numbers for x, the fraction keeps getting smaller and smaller instead of getting bigger and bigger. So what we say is when the power on the bottom is bigger than the power on the top, this is the horizontal asymptote is just going to be at y equals 0. So the horizontal asymptote we would say is y equals 0 in this case. So watch out for that.